Hello friends, my name is Frank. Um, Today I am going to do a different video. This time is a pretty much advanced video to do a lot of scripting inside FreeCAD to generate models based on other models. So as you already know, in FreeCAD everything is parametric, so you can define the attributes of any model based on parameters from a spreadsheet, for example, or from other objects, and you can change later these values and it will reflect in the model. This is straightforward. What I'm trying to do today is a little different. I want to create a base model, parametric of course. So in this case, to make it simple, I will do this video with a simple bolt. So I will create a bolt template that is based on some parameters. For example, the length of the bolt, the diameter of the bolt itself, the diameter of the head of the bolt, etc. And these parameters will go in a spreadsheet. So usually these parameters are in one row in the spreadsheet. You can have diameter in the one column, and in the next you will have length, etc. But this time I want to generate many instantiations of this model. So I have to create a table with different combinations of diameters, lengths, etc. And I want that FreeCAD generate from this spreadsheet with parameters. For example, I can design here 4 different set of parameters, 4 diameters, 4 lengths, etc. blah blah blah, and a parametric base model. And then I want FreeCAD to generate one model per row in this spreadsheet. So this is very useful when we have to use parts with small changes in another models. The bolts are not a perfect example. In any machine or whatever, you need a lot of bolts with different lengths, for example. But bolts is not a good example in this case, because there is also the bolts workbench that create bolts, etc. But I select this model because it's simple to explain what I'm trying to do, and you can use any model. Yeah, you can create, for example, a base bearing, for example, and set a list of bearing parameters and generate all kinds of bearings combining these parameters with the base model, and many other things. The idea is that your parametric model becomes a template that can be merged with data from a spreadsheet and generates all the variations of the template when applying the parameters in the spreadsheet. And also important is that if you change anything in the spreadsheet, all models will be automatically regenerated with the new values. So automatically the model template will be combined again with any changes in the spreadsheet, and all the generated models will get updated. That's it. That's this the purpose of this video. So let's get started. Okay, the first thing to do is to create the model. In this case, we will create a very simple bolt. So new object, new file, save this. Okay, let's create part body, something like bolt. Okay, and let's get started. Create base sketch with base cylinder, for example, in this case. So let's put anything here. We will change later this for a parametric thing. So let's do this very quickly. Okay, we have also this length here. Let's put this here. Okay, we will change it later. Now we need to create the head of the bolt. So this is very simple. We select again this and create an hexagon here. Okay, with a diameter here. Okay, something simple, and extrude this in the opposite direction with some. Okay, so that's it. Now we have a kind of bolt. So this is kind of bolt. Let's do something special here. Okay, this is our bolt. Let's save. Now we want to use this base model as a template to generate different kinds of bolts, different diameter, length, head size, head thickness, etc. Okay, so let's make this thing, this right now this is a static thing, convert this into parametric thing. So the first thing I will do is create a spreadsheet with the parameters. Okay, so create a spreadsheet. Let's call it data. Okay, so we have data here, and this is we will create a table. For example, diameter, length, head diameter, and head thickness. I suppose this is enough for this example. Okay, now and we want to have, for example, 4 kinds of bolts. Let's call it bolt 1, bolt 2, bolt 3, and bolt 4. Any name will be okay, just for the example. So we want a bolt with a diameter of 5 millimeters, another of 8 millimeters, another of 6 millimeters, another of 9 millimeters. We want this one to be 1 inch. Maybe this maybe 50 millimeters, 60 millimeters, I don't know, 10 millimeters, whatever. Now the head diameter, suppose that we want this to be something like 9 here, something like 12 here, 9 and maybe 12. Okay, and thickness of the head, we can say, I don't know, 5, 4, 3, 2. This is an example. So what I want that this model will generate 4 different bolts automatically, parametrically and automatically, so that when we change anything in this table, the 4 bolts will be regenerated with the data. So there is nothing to do here in the spreadsheet. We don't need to define any aliases here or nothing like that, because we will use a special feature in the Nisarco add-ons that is called the script object. So with the script object we can work around this table without defining aliases or things like that. So let's save, and now we need to bind these things with this thing. Okay, so okay, now we need to follow this idea. Now we have this spreadsheet. We have 4 parameters for each bolt: the diameter, length, head diameter, head thickness, and we have 4 variations: bolt 1, 2, 3, 4. We already have a model, but this model right now is not parametric. We need to convert this to a parametric thing, and when we have this both thing, we can generate that. So in order to make this model as a template, we need to define the variables that can change, and we will define that variables in this script object. So we will define some properties here that will drive this model, and we will bind these properties to this table. So any change in this table will modify these properties here, and these properties will drive changes in this model. And later in the same script, we will tell the script to iterate through this table, generate, update this model, and generate one copy for each row. Okay, so the next thing to do is to create the script object. So here is the script object in the nisarcutils. We will do a name. Let's call it, for example, magic. Okay, the initial script generated by the utilities, it has some examples, but we will not use anything of this. We'll start from 0. Okay, we know that we need something to bind to the diameter, length, head diameter, and head thickness. So we need to define, and we need to bind to this data object. So the first thing to do is to define the data spreadsheet. So we will define something like data that will be spreadsheet data, and we will bind this by name. So this object is called data. Okay, and it's in the current document. If this spreadsheet is in another file, in another document, we can set the name of the file, for example, file X hash the name inside the file. Okay, but in this time everything is in the same file, so we have this spreadsheet data. We need to define something to select which bolt we will generate. So we need something to select the configuration. So we will call this, and this will be selectable by the user. So we will call this, for example, variation would be, and this will be data select. Okay, I have just created it. Okay, so in variation it will be user selectable list of attributes that where we can select from this. Right now, let's try this right now to see what is happening. At this point, this magic object has defined this variation variable, and it is automatically bound to the columns in this data, right? So because we have bolt 1, 2, 3 here, etc., it is generated here as options, so we can select on any of these. We are doing nothing with this right now, but is already there. So if we change the name, for example, here, I don't know, bolt XX, yeah, now recalculate this. Okay, Now the options are bolt 1, 2, bolt XX, etc. So this is bound to the to this table. Okay, let's save just to for security. Okay, so this is our table. Okay, this is our magic object, that is this script object. We are working on this right now. This is I call it magic. Okay, so we have now a mechanism to select which variation we can generate if we do it by hand. So let's define the variables to work with this thing. Okay, open this and open this to make it easy. So now we have to define 4 parameters. So we will do this very easily because we can define some parameter called d, for example, for diameter, and d must be bind to this spreadsheet. How can I bind it? Very easily. In d we need data, that is our spreadsheet that we have get here, dot cell. Okay, what cell we will want to have in D? We need the cell that we need is the combination of the column B with the selected variation, right? So we need variation and we need column B, right? That's it. This will be our D parameter. Let's do the same with length. Let's call it L and return same thing but in column C, right? And let's do the same for everything. We have a head diameter in column D and we have a head thickness in column E. So at any time, at any point in time, the parameter D will contain the value of the column B on the row selected by the current selected variation, right? Variation in B, variation on C, variation on D, and variation on E. Let's check this. Now, if you look at this object here, magic, it contains now more variables: D, H, HT, and L, and they are bound to this selection. So if we select bolt 2, they change to the values of bolt 2. If we select bolt X, they change to the bolt X values. If we select bolt 4, they change to the bolt 4 values. So this variation selects these objects, and if we change anything, for example, we are in bolt 4 and right now it has 9 in the spreadsheet. If we change the spreadsheet in bolt 4 9, for example, for 8, it will automatically change here because it's bind, right? 8. So any change in this spreadsheet will be reflected here, right? Now we can use these variables to drive this model very easily. So this is the model. The initial cylinder has a diameter and a length. So the length of this object can be set parametrically to our magic object that L, right? Okay. The diameter of this thing could be matched to our magic dot D, right? Okay. Then the head of this thing, the thickness of this operation could be magic dot head thickness. Okay, and the diameter of this hexagon here, this constraint will be, or magic dot head diameter, right? Okay, so right now our model is fully parametric. If we select any variation here, for example variation 1 is this model is updated, variation 2 this model is updated, variation 4 this is variation 4, and variation 5 is this model, right? So the model is fully parametric and can be changed by selecting the variation, or also can be changed by modifying the spreadsheet. Let's put this in Windows so we can see better. So if we change things here, let's say we are in variation 4, so this, if we change things here, like for example here 50, it will affect everything in the model itself. Yes, head thickness is too low, so 6, right? So the model responds to the changes in the selected variation, right? If we select another one, for example XX, now in XX we can change this here 20, that's it, right? So right now we have two kinds of things. We have this model is parametric. The parameters are D, L, HD and HT, but these parameters are also selectable by bolt 1, 2, XX and 4. Yeah, that's the variation. So, and we can select any of these variation at any point in time. Now what I want to do is, we already have our data, we already have our template parametric model, we already have our script object. Now I want that these 4 models gets generated, all 4, no one by one or one at a time, but all 4 all the time. If I change anything in the table, the corresponding models get updated. Let's do it. Okay, let's continue. We have our parametric model, we have our data, and everything is binded together. Bold 4, 4. If I change here, for example 8, it will update. Okay, what we want now is to generate the 4 models based on this template. So the thing is, in the script object we will add 2 lines to specify. First we need to generate something, so from data, we add a generator. Our generator will be based on this object, this template object is named bolt in the current document. So we have doc bolt, and our variations are based on this attribute variation. So we add the generator based on the model and the possible variations, and finally we tell the thing to generate all. That's it. At this point the script will bind these things and finally generate everything. So let's try it. That's it. These 4 variations were generated from the original bolt object. Let's hide this like this, like this, like this. So this is one variation, this is another variation, this is another variation, and this is another variation, and all variations are binded to the data sheet. So if I change anything here, it will update there. For example, I need to make this bigger, 20 for example. Now you can see the change there, maybe a little more. Yes, you can see that that version was changed. Okay, now that we have all our variations, we can try to put everything apart using maybe containers. Let's try this. I will move this here, create another thing to put this, another to put this, and another one for this. So now I can move them apart. So we can see better the changes in the models. So let's change something here. Yes, or here, yeah, or even here. Yes, everything is bound. Four models are updated based on the same geometry, the same bolt models for things, and everything is updated accordingly. Okay, that's it. I will publish this as soon as I finish some things and fix some bugs, etc. But that's the idea. Thank you very much.